Right, linear programming. Okay, very similar to the linear inequalities we've just been doing. Remember where you graph, you shade, you've got a common area, okay, where they're all shaded. You've also got the vertices. We've also got an objective function in linear programming. Have a look at the procedure down below. So graph the region of feasible solutions, okay? Linear equations, graphing, shading, less than, greater than. Determine the coordinates of the vertices, remember where they cross, wherever they are. And also evaluate this objective function. It's for maximizing or minimizing. And the great one is always profit. So here we go, maximizing profit. Okay, bookcases and desks. Bookcase, 5 hours of woodworking, 4 hours of finishing. A desk, 10 hours of woodworking, 3 hours of finishing. But each month, the shop has 600 hours labour for woodworking and 240 for finishing. What we're doing here is let's have a look. X is bookcases, Y is desks. What I'm going to do is this. Do a woodworking equation. Right, look at this. 5 hours of woodworking on a bookcase. X is bookcases. There we go. 5 hours for a bookcase. 10 hours of woodworking for a desk. So Y is desk, 10 times Y, okay? So 5X plus 10Y. 5 hours for a bookcase, 10 hours for a desk. And it must be less than 600 hours. That's all that's available for woodworking. So this is a woodworking equation, okay? I'll just call it that. That's woodworking, okay? X is the, what's that? X is the bookcase, Y is the desk. How about finishing? Right, 4 hours of finishing for a bookcase, so 4X, there it is. 3 hours of finishing for a desk, 3 hours for the desk. Must be less than 240, that's the most you have. Okay, so we're going to graph those two, but also remember our objective function, because to maximize profit, it's $40 for a bookcase, the bookcase is X, 40X, and it's $75 for a desk, so 75Y. That is our objective function, to maximize profit, okay? Right, so we have those two equations we've got to graph. We've got to graph this one and this one, okay? Do that first. Ignore this for now, okay? Okay, here it is. Now remember, in the real world, everything is greater than 0, okay? So we're only plotting it in the first quadrant, okay? So let's have a look. We have the two equations. We've got this one and this one. And these other two just means we're in the real world. Everything has to be 0. In other words, again, quadrant 1. We're not graphing here, here, or here. Okay? So, when x equals 0, y is 60. Okay, so that's this one. So this one, let's have a look. I'll make sure. So when x equals 0, y is 60. So this is that equation. Okay, that's that line. When x equals 0, y is 80. So this must be, well, I'll go up here, this equation. So this point here was 0, comma 80, the y-intercept. Okay, I'm going to write it in. I mean, I need it to graph. I don't need it for the vertex. Okay, so that was the y-intercept. The x-intercept for this, when y equals 0, x equals 60. There it is. So again, that line there, I've drawn both lines. Okay, and when I do test, I can test the 0, 0 point. It's available. And yes, 0 is less than 600. Basically, I'm shading both sides of this line, okay? Down here, down here. This is getting shaded, so I'd be shading less than this one, but the common area is this here, okay? So it's got vertices at 0, 0, because that's fairly obvious. You can see this is 0, 60 here. You can see this is also 60, 0, just from the graph. What I don't know is this one, but it's solving these two equations. Okay, elimination by addition. So if I multiply this one by 4 and get, let's have a look. Multiply by 4, I'll get 20x plus 40y equals, times multiply 2400. So I multiplied everyone by 4. Okay, so that's times 4. This one by negative 5, because of this I'll get negative 20x. Okay, negative 20x. That by negative 5, negative 15y. And that by negative 5, what's that? 2 to carry 120. So that is negative 1200. Okay. So I'll end up with, let's have a look, 25y equals 1200. And if I divide that by 25, I should get y equals 48. Let's just have a look. So 1200 divided by 25 equals 48. When I put it back in, I'll get y equals 24. So x equals 24. So I have just found my vertices. Now what you do now is you put all these points, you can pick any single one of these. You put it into here. You replace the x and the y with whatever you found for everything inside these circles. And they'll do the 0. You know that this one's not going to work. Okay? Okay, those are the 4 vertices. If you look down here, they've put them all in. And it looks like the one that's got there, this one is the one that maximizes your profit. In other words, if you do, what was it? Was it 24 bookcases and 48 desks? Okay. Now don't always assume it is this one. This one came quite close. Look at that one. That was 4,500. Look at that. That was 4,560. So when I used this, the X and the Y, it gave me the biggest value of P. I just maximized profit. Okay. Again, I'm testing all the 4 vertices in the objective function. Okay.